what this decimal numbers? Okay, the decimal numbers or decimal places, I think this is not very common for you because you already studied that in your secondary school. Okay, and just a recap, a few things here. So all digit in a number after a decimal point on the right side, they call as a decimal places. All right. So this is one of the crucial in the numerical method because these decimal places will determine whether, say, you're going to launch a rocket, whether they reach a target or not, because it depends on the decimal number that you choose. If your wrong decimal numbers, it could end up somewhere else. Okay. So the decimal number is one of that significant in a numerical method. All right. For example, you can see that in the table. All right. You can see that the decimal points. Okay. The 14. Okay. That is we call that is a zero decimal because there is no any numbers after the point. So this could be a. So there is no numbers. So zero numbers. So it means we call it zero. 0.25, obviously after the point 0 point there is two numbers exits because so we have a two decimal places. And then look at the example 3, 0.059700. So I think most of you make a wrong because they only look into these four numbers, 4 digit, 1 2 3 4, they forgetting this. But remember, in mathematics, the zero whatever exit after that the points is counted for in order to see the decimal number. So 1 2 3 4 5 and 6. Okay, so you should say that it is 6 decimal numbers. So you define as a 6 decimal places. Okay, so here as well the 10,000, there is no any numbers appeared after the point, so due to decimal numbers. And then this is years, they give it 100.000000. So that means is a 6 decimal places exceeds. If you could see that, you need to write back the same things. All right, you not just give your answers just 100 because it's wrong. You should consider the number which is given, the decimal numbers. This could be there is a 1 down there, so we do not know. So you just leave it that the if it is given this way, so you should mention that it has a 6 decimal places. Okay, same thing goes to this example 5.000001, and the last one you can see that whatever the numbers even at the last, so you need to read everything go, so it should be 7 decimal numbers. So that is importance of the decimal number, and try to memorize how you can read and see the different pattern of the numbers in order to look into the decimal places. Okay, now significant figure. So you see there is a difference between decimal places and significant figure. Okay, so we can see what the differences is. Okay, all right, in digit, okay, number of starting with first non-zero digit until the last non-zero digit or non-zero decimal, they call as a significant figure. Okay, for example, you could see that the table, say there is a two numbers 1 and 4, so we call it is a two significant digit or two significant figure. And look at this, after the point there is a number, it's a non-zero number, so 2 5, so we call as a two significant figure. And after, so you should count everything on go. And as well this same things, you can see that and the last one, okay, so the first non-zero digit is appeared here, so it count one significant digit or significant figures. Okay, so you should identify what is those differences. Okay, so yeah, 2, okay, 1 2 3 4 5. Okay, so these are non if you look at the example 3, so it's a non-zero 0 digit is appeared, so I mean it comes from 5 9 7 0 0, so I mean it start from here 1 2 3 4 5. Okay, 5 figures, this is 1 and the remaining 0, and the same things the rest. Okay. All right. So this is how you need to differentiate the significant figures and the decimal numbers. Okay. All right. When you come to that in the significant figures and decimal places, okay, there is a two type of that accuracy. One is we call is a precisions. Okay. Another we call as a accuracy. Okay. There is a difference between precision and the accuracy. What does it mean precisions? So precisions is something like the pointing one point is don't have to be accurate, but most of the target point is just in the certain places they focus on. But accuracy, the actual one. All right. So the decimal places is a precision is give you that exact, the area which is the other point is belong to. And the significant figure is a accuracy of the numerical value. So you can see there's some in this diagram. You can see that the difference between the accuracy and the precision. Okay, look at that. The first high balls, they call as a high accuracy and high precision. So when you come to high accuracy, that means it is accurate at the point at the center, and the precision, all the targeted shoot is appeared on that the same point. So this call a because all the points, the targeted point is one to closer to one to another. So that means we call high precisions. Okay. Next, low accuracy but high precision. As you can see, low accuracy because all the targeted point is away from the center, but is appeared on this section. All right. But is as a high precision because all the targeted shoots as close to one to another. All right, so this we call high precisions. All right, next you look at this diagram. Okay, this one. So high accuracy because all the targeted point is towards center, but it has a low precision because the targeted shoot is slightly is away from one to another. Okay, there is a distance not close to one to another, but is away from one to another. Okay, these called as a low precisions. Okay, and obviously you can see that the last diagram, the high balls here, is called as a low accuracy because there none of target shoot is not appeared on the center, but it just scattered around that the eyeballs, and as well the targeted shoot is far away from that one to another. So we call as a low accuracy and low precisions. Okay, so this is how you need to classify the two things. Okay, the precision and accuracy when you come to make a decision on decimal places and significant figure. So decimal places, as you know, is more on precisions, and the significant figure is more on accuracy. Okay. 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 Okay, the computer operation, usually the computer arithmetic is, we call the arithmetic operation done by the computers, all right, not a human, all right, it's done by computer. Okay, so for example, in the form of the integer, okay, and the form of a fixed point, and the form of the floating point. I think you're familiar with this floating point. Have you heard floating point before, guys? When you do your structured programming in C++, they come out the floating, double floating. Remember integer?
Yes.
Do you? Yes, very good.
Yes.
Okay, that's all we call as a computer arithmetic. We have to declare in the math, all right, the math command, and then you can write all these statements so that the computer able to calculate the things. So usually the floating point will be the 7-digit, okay, in C++. The floating data, okay, the floating point usually will be is a 7-digit numbers, okay, and that the double long or double float, okay, you use the double. Remember that in the when you write a programming, so when you declare the double, so or a long float, okay, which means it has you can express that the 16-digit figures, okay. And then long double, he has a 19 digit and so on. So, okay. So I think just for your knowledge, I think for next semester, you will learn how to write a programming, because usually this subject, all right, mainly we use a computer in order to calculate the solution. So for example, we use the software, regardless C programming, C++, okay, MATLAB, ANSYS, okay, Fortran, okay, Maple, MATCAD. We have plenty of it. Okay, you can choose either one of these software, so you can able to do that the calculation. All right, sometimes because we involve the large data size. Okay, the large data, large metric size. So that we had to do our calculation based on that the programming works. So you just address, I mean, you write the coding, and then you let the computer done for you the works. Okay, it's pretty fast. But if you do manually, yes, it will take days, maybe a month. Okay, if you do it computer, within a minute, okay, an hour, you can get a solution. Okay. All right, so this is a great research still ongoing now and very hot topics. All right, so if you wish to do your research on this area, all right, you're always welcome for the next semester for the scientific project. Okay. Now, next, when you come to computer arithmetic, so all remember that all the number are stored and processed. Okay, the number are stored and processed in that NDFP form. They call a normalized decimal floating point. In short, we call NDFP form. Okay, so NDFP form is a we call a Mantissa. Okay, Mantissa. Okay, all right. Let's see what is the Mantissa. Okay, so usually it will be expressed x equal to plus minus 0.d1 d1 times di times 10 power of n. Okay, so which mean, oh, it's not in sequence form. Okay, say for example the numbers, say the actual numbers is 0.0000024593. Okay, so in order to write in the normalized decimal floating point or NDFP form, so you can write in the form of Mantissa. So this we call a Mantissa. Okay, 0.245993. So you just move that the figures 1, 2, 3, 4, 5. So there has to be 0 point. Okay, not a given in the standard form. It's just in the we call a Mantissa form. Okay, or otherwise, in other word, we call as NDFP form. Okay, so there has to be 0.245993 times 10 power of minus 5. As well this. So if it is 21.36569, so in terms of NDFP forms, this will be, you can write as this. Likewise this. Okay, you can convert into that NDF forms. Okay. Okay, so the D1 usually it is make sure it's a non-zero value. Okay, they are not must be non-zero value, and the DI, okay, the DI can be between 1 to 9. Okay, the same time remember the D1 can be any the numbers. Okay, any numbers. Okay, plus minus any numbers. Okay, all right. All right, Mantissa. Okay, as I said just now, right, Mantissa. Okay, the Mantissa is that the numbers from 0, D1, D2, D3, and so on. So they call a Mantissa. This is all we call a Mantissa. Okay, 0 point D1, D2, D3, Mantissa, which means the 0 point D1, D2, D3 has to be between 0.1 and less than 1. Okay, it's appeared between this range. Okay. So the Mantissa and the index numbers and as a limited size in computer. Okay, so based on that, as I said earlier, when we determine that the floating, double floating, okay, or double or long floating, okay, long double and so on. Okay, so based on how we can determine, because the computer's arithmetic is you need a required great memories, and depends on that what bit you're using at the moment, and based on that you'll be able to run a programming. Zulaika Akila. Oh, just register. Okay. Thank you, Zulaika. Okay. All right. So this is basically Mantissa. So you should understand when look at this form, they call it a Mantissa, and this is a range of the Mantissa we should be extract. Okay. Any question, guys, so far? Any question? Is it clear?
Yeah, I think for now everything is clear.
Okay, thank you, Adam. Okay. All righty. Next, we just move to next slide. Okay, take a look at the k-digit decimal floating point. All right. Now, usually the k-digit floating point you can represent in the form of a floating. So FL, this remember, this is a stand for floating, float X, they mean FL. So represent in the Mantissa form, which is plus minus 0 point D1, D2, D3 until dk minus 1 and dk times 10 power of minus n. Okay. So for all m less than n and n less than or equal m. Okay, so this is the k-digit decimal floating point forms. Okay, so usually there is a two-way where you can able to determine that the dk. Okay, so dk is here. The two-way. So one is you can represent between 0 and 4. Okay, the another way is you can represent dk plus 1, which is in between 5 and 9. Okay, so remember that. So this is we need to use in order to round off number. Remember that by common, in common tongue, we just use that the round off things, right? Say for example, 0.0355. Okay, what would be that the round up number? I mean the greatest hundredth for this number. Anybody can tell me?
0.036.
0.036. This is what that the how we do. Okay, but the computer it's not do in that way. Okay, the computer will read as 0.035. Okay, because the computer use that the chopping arithmetic, arithmetic in order to represent the data. It's not a human way to do the calculation. Okay, that is that we need to develop the programming based on this. Say we not declare any programming works, any statements, command, the computer will read, say the if you just give the numbers, a certain amount number, so it will chop, say this is a 1, 2, 3. So the 3 decimal numbers, say for example, the computers just assume that is a low capacity of the computers and it's only read up to this point. It's not got round up to 36. Okay, we call it a chopping. Okay, we call a chopping arithmetic. Okay, the chopping numbers. Okay, or chopping forms. Okay, so this is how the computer read that the numbers. All right, but in humans we just round up usually. So you must see the differences between these two things. Okay. Okay. All right. So the round off number usually will be, we can express, you need to declare in this form. So dk, so the numbers you need to express this form, dk between 0 to 4 and dk plus 1 is has to be declared between 5k so that the computer able to read that the round off numbers. Okay, the chopping of numbers, you just leave it as it is and it will chop exactly the what I said just now. All right, the number will cut off at the point. It's not going to be round up. So always when you do the programming, so you have to give the statements. in order to the computer able to give that the round up number nearest 10th or 100th, 1000th and so on. Okay, otherwise the computer will chop exactly the numbers on that the spot that what is declared. Okay, based on that the declaration based on the commands. We'll see some example. All right, how it is works. Okay, the chopping of number and round off numbers. Okay, now take a look at the solution. Okay, so if that question A, if it's 0.3244, okay, regions were correct. Okay, so there will be round up to, if you use the round up numbers, so it will read as 0.3245. And then if it is chopped, it will become 0.3244. Okay, so likewise, look at this example. So you can see that is in the form of Mantissa. Remember, guys, there has to be right in that NFDP form. Okay, so will be read as 0.4666 if it is a round up. Okay, so if it is a chopped, it will read as 0.4599. So you can see the differences. Okay, so what if you just use the floating point in the computers? So what will happen if it is just give to the floating point rate that the things, because it's floating point only 7 digit. Okay, only 7 digit. So if you just leave it as it, so what happened? So 1 2 3 4 5 6 7. Okay, so it will not give that the accurate solution as we wish. So we need to write a additional program, so in order to read exact solution what we desire. Otherwise the computer will chop that the decimal numbers according to that the declaration what we done. So if a long double, if a double, then you can get accurate. If it, since it's float, only 7 digits involved, so then it will read based on that the figures. Okay, example 3, same thing. Okay, so when we just round up, okay, the 4 decimal floating point, so if it is just given in the form of a roundup of number, so it will be given 0.1376 times 10 power of 6. If it is chopped, so it will only give you 0.1375. So even you can see it's a very minimum difference, but remember numerical method difference, right? Remember every numbers is very, very significant. Okay, so the accuracy is important in the numerical methods. Okay, so I'm sure you're very clear with that, what is the chopping of numbers and as well as the rounding of the numbers, so the differences.